This is topic 6.10, 6.11, 12, and 13. The last 4 topics for energy. So let's get started. Remember, at the top we have our objectives, learning targets, etc. So make sure you follow along on your study guide. Okay, another energy source you have to know is geothermal energy, which comes from underground. Okay, so remember that there's magma. We learned this in Unit 4. And in some places on Earth, not everywhere, but in some places on Earth, the magma comes close to the water table underground. So our groundwater and our water and magma are close to each other. And the magma heats up the water naturally. So there is a way to pump up that hot water into a power plant. That hot water steam spins turbines, and then you pump it back underground. And so that's what happens in a power plant. So again, you use turbines to use the steam to spin turbines, just like a coal or a natural gas power plant or a nuclear power plant. But this time you don't need any fuel to heat up the water. It's naturally hot from underground. Again, it's not everywhere on Earth. It's not where I live. If I pumped up groundwater, it's not hot. So this is in specific places in the world. There are some other ways to use the earth itself to control the temperature of your house, and we'll talk about that. All right, so which country has the highest rate of geothermal? It's Iceland, because if you remember from Unit 4, when you studied plate tectonics, Iceland sits on the mid-Atlantic ridge, which is a divergent plate boundary and has active volcanoes. So anywhere you have an active volcano, you're going to have your magma close to the surface. So geothermal power plants, as you can see down here, have very little air pollution, no greenhouse gases, and it's renewable if you don't overpump the groundwater for things like agriculture. Drawbacks. Now, naturally heated water underground contains sulfur, and so this releases hydrogen sulfide gas, which is an air pollutant. And again, now in these power plants, they're going to use that heated water and then inject it back underground. But if you overpump your aquifers and your groundwater for things like agriculture or drinking, then you could deplete the water table and make the water table go too low to be useful. So you can deplete your groundwater and it can't be used for geothermal. Okay, so why is it limited? Again, I told you it's only where magma is close to the crust. This does not occur everywhere in the world. You're going to see some geothermally active areas. You can see in the western United States has more geothermally active areas than the eastern United States. But I live in California, and where I live, it's not geothermally active. So it's not even everywhere. And even if it is, it might not be particularly accessible for geothermal power. Okay, now this is something called ground source heat pumps. This is an interesting technology, but it is not going to be on the AP test. But basically you just, and during the winter, you pump cold air from your house down underground. And remember, the ground is going to be like a consistent temperature underground. It's going to be maybe like 68 degrees underground. So it can, if you pump air down here, it can heat up air in the winter. It can cool down air in the summer. And you just keep circulating it like this. So buildings use this, eco-friendly buildings use it, homes use it. It's an interesting technology. All right, let's talk about the next one, which is hydrogen fuel cells. So a hydrogen fuel cell is an electrical chemical device that converts fuel like hydrogen into an electrical current. It operates like a battery, but the electricity is generated in a reaction between two chemicals. So basically you use hydrogen gas as your fuel. So if there are cars that actually have this technology, and some buses, you fill up your gas tank. It's not gas, but you fill up your fuel tank with hydrogen gas, and then oxygen you just get from the air, which gives you energy, and your only byproduct is water, which is great. So it's a really promising technology, but there are some drawbacks, which we will go over. This is a little picture of how it works if you would like to know a little bit more You can pause the video. So here's a couple other pictures. You do need to know a little bit about how a hydrogen fuel cell works, but let's go ahead through our PowerPoint. So first of all, the benefits of this is no other pollutants are released when a hydrogen fuel cell is used. Disadvantages. Well, hydrogen gas is explosive, it's difficult to get, it's difficult to extract. The current way we get hydrogen gas for these cars is we do the process called electrolysis, where you run an electric current through water. It splits the water into hydrogen gas and oxygen gas. It was actually something that when I was in high school a very long time ago, we actually did this in lab. It's a little bit too dangerous. They don't like high schoolers to do this anymore in chemistry, but we used to create an explosive gas in high school chemistry class. And so we would electronically, we put an electric current through water. We create and we collect and create hydrogen gas and then light it on fire. Anyway, fun old days in chemistry class. All right, now the problem with converting to hydrogen is that how do you split that water? So it's going to take mainly fossil fuels to create the electricity to split the water. We don't have enough solar or wind power to do this process. So until we figure out how to get hydrogen without using fossil fuels, this technology is really not going to be the best technology. There is some research into using algae. Some algae emit hydrogen gas. Right now, that's a really expensive process. So until they figure out how to make that cheaper, to make hydrogen gas cheaper, it's not particularly viable. So let's talk about wind energy now. So wind energy is generated from the kinetic energy of moving air. It's the fastest growing major source of electricity in the world. Again, it's not enough. If we want to use wind for electricity in our houses to replace fossil fuels, we're doing that very, very slowly. So even though this number has gone way up, this is still a fraction of our electricity supply in not just our country, but the world. In order to replace our electricity with wind and then have enough wind to do electrolysis for hydrogen cars, that is a very long way in the future, which is why hydrogen cars, they're not really pursuing that as much. We haven't really figured out the solution to that problem. And so that's why a lot of cars are going to hybrid or electric. Anyway, back to wind. It's growing very fast. You need to know the top 3 countries that are using wind: China, the US, and Germany. The US has some of the highest wind capacity, so we have very windy areas of the country. Only 8% of our electricity comes from wind, but it is the fastest growing source of electricity in the US. Some countries that are much smaller, like Denmark is a much smaller country and generates 47% of electricity from wind. So you can see here that this is the wind capacity in gigawatts. So China is first, then the US, then energy. And this is percentage of their own electricity. So Denmark's first with 47%. But if you look here, that's about 10 gigawatts of power, makes up 47% of their electricity. You have to keep these numbers straight. So remember, Denmark is a small country and China is a big country. So even though China produces the most gigawatts, it's only about, about 6% of their total energy or electricity. So keep those two numbers or those two kinds of statistics straight in your head. Okay, so how does wind energy work? You have your turbines, which are the blades. So the blades are the turbine. It converts the kinetic energy of moving air into electricity in the same way that hydroelectric turbines harness the kinetic energy of moving water. So our towers can be very tall, and the turbine is the blade. Inside is our generator, and then down in the shaft right here, you have wires that go to the electric grid. Okay, so again, the parts of a windmill: blades, turbines, generator. The wind turns the blade, which spins the turbine and generator. Now, there is a different type of wind energy, which is a horizontal wind turbine. Most of the time we see this is called vertical. Horizontal is parallel to the earth and it's more efficient. Vertical is perpendicular to the earth and takes up less space. Okay, so let's talk about offshore wind farms. Why do people put windmills off the coast? And you can see that in some places. When I was flying across Europe once and I looked down over Denmark and Amsterdam, I saw Amsterdam's the Netherlands, Denmark is Denmark. But in that area, there were a lot of offshore wind turbines. The wind there is more consistent. It's pretty much because of weather patterns constantly blowing. Let's talk about what NIMBY is. NIMBY means it's an acronym for not in my backyard. Some people do not want to see windmills or landfills or power plants, but they want the benefits of them. How can we minimize impacts to birds and bats? Because birds and bats hit windmills, which is bad. We want bats. Bats are super important to eat pests and bugs and to help our crops and our food supply. And so we don't want to hurt these critters. They're super important ecologically. So there's a lot of experimentation. Smaller blades tend to keep out of the paths of migratory birds. Some place beeps and special sounds that scare the bats away so they don't hit the blades and die. This is down here is a picture of a prototype of a wind turbine where there aren't blades. The blades are actually inside this little capsule, and that helps the bats avoid getting hit and dying, and birds as well. Okay, so wind turbines are installed in rural areas near electrical transmission lines. And then wind farms are increasing globally, but can be built offshore near water. We talked about that. Pause the video and fill in your study guide for the benefits and disadvantages of wind energy. So actually you can pause it there and fill in your chart. All right, let's talk about conservation now. So know the term phantom load. Sometimes it's called vampire load. It's when you plug in a device, even when you don't turn it on, like cable boxes do this, gaming systems do this, they're constantly like checking for data that they want to download. Well, they're using massive amounts of energy even when you're not using that device. So trying to eliminate devices with phantom loads or vampire energy is a way to reduce energy use, conserve energy. Governments can increase taxes on electricity, oil, and natural gas and discourage the use of energy in certain ways. So if you're ever asked for a way that governments can help with energy conservation, you have to be specific. You can't ban all cars or with fossil fuels. You have to work with a democracy, and as a government, you can't build cars in a democracy. It's the private company. So how can you help private companies do these things? So, or cities or states or whatever. Here's what you can do. You can offer tax credits or rebates. So tax credit, tax rebate to encourage things like hybrids, plug-in electric, battery electric vehicles, Teslas, etc. So going back to this real quick, we're going to talk a little bit more about what governments can and cannot do, but always think about tax breaks, subsidies. Those are the key words that you want to put on an FRQ. Okay, ways to conserve energy. You have this chart on your study guide, so make sure that you summarize it. You can either, if you want to summarize in just a few words, you can do that. If you want to write them word for word, you can do that. But pause the video and take a few minutes to do this. Okay, so there's also something called peak demand. So energy use, you can see by this diagram that there's lower energy use from 12 a.m. to maybe 1. And then from 1 to 3 is more, especially in hot weather or cold weather if you have electric heaters. And then, well, I'm thinking more air conditioners. So in the summer, it gets hotter and hotter and hotter, and super hot, super peak time for electricity use. and then it lowers. So you can incentivize people not to use much electricity in those times. You can encourage people, like in my area, they're like, they say, don't, in the middle of summer where everybody's running their air conditioning, don't run other appliances, like don't use your washing machine or your dishwasher. Wait until later in the evening or earlier in the morning so that that electricity use doesn't put a strain on the electric grid. You can also charge more for different times per day. And so this is something also that electric companies do. So it costs you less money to use energy here. So if people want to get on that type of plan, you can choose, at least where I am, you can choose the type of plan you want. And so people can do their electric uses, wash their clothing, etc., cool the house down before 1, and then hopefully it's cold enough to last until 7, until when the electricity is cheaper again. So that's peak pricing. Okay, so you can also have passive solar design in the construction of homes and buildings to heat your house so you use less energy. You can also increase the thermal mass of a home, which is like using bricks and other things that hold hotness. So during the day, they can heat up and release heat at night. These are in your cold climates. And in Unit 5, we studied a little bit about green home technology. You can review that a little bit with insulation and high efficiency windows and skylights, insulated foundation walls, high efficiency heating and cooling systems. So these are all eco-friendly home things just for conserving energy, not for other eco-friendly features. Here's a review of passive solar technology. So again, you want windows that absorb the heat from the sun in the winter when the sun is more at an angle. You have a floor here like a brick, maybe brick under a rug or under your carpet that absorbs that heat. Again, these are for colder climates. And then during the summer, the sun is more overhead and there's an overhang to shade your house. So renewable energy is more sustainable, but may still have impacts on the environment. Each form of energy has advantages, but also has disadvantages. Think of wind power. Birds and bats get hit, so there's positives and negatives. So experts suggest that that new renewables and expanding current use will require innovation of our electric grid. So the grid is how all the wires are connected together, and we lose a lot of energy through our wires. So there is a lot of work being done on a smart grid that would create an efficient, self-regulating electricity distribution network that accepts any source of electricity and distributes it automatically to end users. Now, there are some experts that say we can meet our climate change goals just by upgrading our electric system. So we can still burn fossil fuels, but if our electric system is only 20 or 30% efficient, which means we lose 60 to 70 to 80% of the electricity made at the power plant before it gets to our house, that's a huge loss. So if we can fix that number, maybe we don't even need to switch to renewables as fast. Okay, here's some more specific information, things that have been asked on AP tests before. Why aren't photovoltaic cells, solar panels, considered energy conservation? So on an FRQ, if you are asked, what can a homeowner do to conserve energy? And you write, they can put solar panels on their roof, it's wrong, because you're not conserving, you're not saving energy. You're switching to a more efficient and renewable form, but you're not reducing the amount of energy you're using in your house. You're just switching the type. So you cannot use that term. What are CAFE standards? It stands for Corporate Auto Fleet Efficiency. It's the maximum average miles per gallon of the vehicles a car company sells in a year. It pushes manufacturers to produce more efficient vehicles. What are subsidies? Government payments via tax money to help offset the cost of doing business. It makes prices cheaper for consumers. So you can give subsidies to an industry to help the cost of that thing be cheaper, like an electric car, like wind industry, like the solar industry can get government subsidies. Now, a tax break is like if you put solar on your roof, sometimes a city or state may give you a little bit of money back in your taxes to help incentivize people to do that. And then what are some features of a green building design that helps with energy conservation? Having a green roof, like plants on your roof, LED lights, insulation, double paned windows, landscaping, smart thermostat, thermal mass. And there's just a little picture of some of those things again. All right, and that wraps up Unit 6.